Greetings and welcome, friends. Yesterday, we talked about how to find an angle when I know a ratio. We actually used the trigonometric ratios in reverse, or more specifically, inverse, where, right, a trig ratio, if I give it an angle, it outputs a ratio. A trigonometric inverse, I input a ratio and it outputs an angle, and at this point it outputs it in degrees for us, but your calculator can also output in other modes. So let's see what's going on here. It says determine which of the two acute angles has the given trigonometric ratio. So let's see, 5/11ths. Well, which two sides would have a ratio of 5/11ths? That would be the 5 and the 11. The 11 I happen to know is the hypotenuse. Why is that the hypotenuse, friends? And it's opposite the largest angle, right? Yeah. And it's, the longest side. Well, here's an angle. The side that's opposite it is right there, right? These two sides are adjacent to it. So, yeah, there you go. Perfect. Farthest away, not touching it. Not touching. Let's see. Now, 5, if we're talking about sine, you guys might remember that sine of some angle, I'll just say theta here, so I'm not determining whether it's A or C, is equal to the opposite over the hypotenuse, right? Opposite leg over the hypotenuse. So that means the 5 must have been the opposite, and if this is the opposite, which angle would have that as its opposite? Yeah, it's A. It's the only one. So the answer is angle A. Da-da-da-da. Hooray. Okay, here we go. Let angle D be an acute angle. Use the calculator to approximate the measure of angle D to the nearest tenth of a degree. So here's an equation. They said the cosine of some unknown angle is 0.33. So to get that angle by itself, to get rid of this cosine function, you actually can cosine inverse both sides, right? Like so, cosine inverse both sides. And what that does is cosine inverse cancels out with the cosine function. I get angle D by itself, and angle D is equal to the cosine inverse of 0.33. So I hit second cos on my calculator, giving me cosine inverse 0.33, and I get angle D is 70.7. Tell you what, L honor their tenth of a degree, degrees. Bam. There we go. All right? So that's the idea of how we can use these inverse functions, that if I can write the trig ratio with an equation here, I can then solve for that angle now. And so we put that to use doing something we called solving right triangles. And solving a right triangle means that you were given 3 pieces of information, in this case 2 sides, and knowing that it's a right angle. And solving it would then be finding all other information about that triangle, using any means necessary. All right, so let's go for an angle first, because we can. So I'm going to go for angle G, and from angles G's perspective, the hypotenuse is 16, which would also be true from angle J's perspective. The opposite leg is this unknown length, HJ, and the adjacent leg is GH, right there. All right, so if I want to find angle G, I would need to set up a ratio comparing the two things I do know, which are 14 and 16. So what trig ratio compares the adjacent to the hypotenuse? Cosine, right? So katoa. So I'm going to say cosine of G is equal to 14 over 16. And now if I want to solve for G, I can cos inverse both sides. Now, sine... What? I could, but actually I'm just going to plug it into a calculator in a minute, so I'm not even going to bother. But you're right, that would be 7/8. So I'm going to get angle G is approximately the cosine inverse, second cos, of 14 divided by 16. Close those parentheses, and I get 28.96. Sure, I don't know. Yeah, they said to the nearest tenth, so 29.0 degrees, sure. So you also, if you wanted to do a ratio in terms of sine, that would have been from angle J's perspective. So sine of J would have been 14/16, and the sine inverse would have given you angle J. Let's actually just write that for fun. Although once you know one angle, you can find the other, knowing that those two are going to be complements of each other. So sine of J is equal to the same 14/16. And to get J by itself, what do? Sine inverse, which I like to call sinverse. Sinverse, both sides. So J is going to be second sine inverse of 14/16, close parentheses, and I get 61.04, right, which we'll just call 61.0 degrees, right? And actually that's always an approximation, or mostly always, unless it's like a 30, 60, 90. So 61 degrees. Now that's two pieces of information that I have. What's the third piece I need? HJ. What is one way I could find that? Pythagorean Theorem. I can use that because I know two sides. What's another way I could find that? Yeah, I could use cosine from J, comparing this unknown dimension to 16. I could say tangent of J, saying 14 over this dimension is equal to the cosine of my new J angle. I could say sine of G is equal to this over 16, knowing that sine of 29 now is equal to that, right? And I could even say tangent of G is equal to this over this. So there's actually lots of ways you could set it up. Or like I said, we could use Pythagorean Theorem. But the trig inverses are newer for us, so I'm going to use a trig inverse. Let's see. Someone said cosine of J, so I'll use cosine of J. So that's cosine of 61 degrees is equal to HJ. I guess I'll even write it out. Tell you what. Over 16. So to solve for HJ, what do? Yep, multiply both sides by 16. Cosine of 61 is just going to be some ratio, some number, right? So HJ is going to be approximately 16 times cos 61, not cos inverse, and I get 7.76. Now, you should kind of check the reasonability of your dimensions, right? Is this, in fact, the smallest side because it's opposite the smallest angle? Yeah, it is, right? Because sometimes sometimes the math ended up being where we're supposed to do 16 divided by cos instead of 16 times cos, right? And yeah. So if you did that, you'd end up with a larger number rather than smaller. And so just pay attention. Like, do a gut check at the end of all your dimensions. All right. Ooh, I like this one. All right. Solve each triangle. Wow. Okay. So, what's up? Yes. Yes. Yep, you could leave that as a reduced radical, and yours actually would be more accurate than my decimal approximation here. 2 times the square root of 15 is what they say. So, okay. All right. I don't have any angles on this big triangle. Let's work with this little triangle first. So, we've got 64. I know 4 is which side? Is that the opposite, adjacent, or hypotenuse from the 60? It's the adjacent leg, right? I could find the hypotenuse, and I also could find the opposite. So let's find that. Let's find the opposite. So to find the opposite, I want to compare it to the thing that I do know. What's opposite over adjacent? What trig ratio is that? Tangent, right? TOA. So I'm going to say tan of 64 is equal to ut over 4, right? And so ut is going to equal 4 times that. All right. I'll write out my step. It's pretty much the same amount either way. Multiply both sides by 4. Make sure your calculators are in degree mode today, by the way. So ut is going to be 4 times the tan of 64. I got 8.2, I'll call it. All right, so I can even label that on my diagram. Let's find the hypotenuse. I'll do that using comparing the adjacent to the hypotenuse, which is cosine. So cosine 64, adjacent is 4. Don't just assume that your variable is always going to be in the denominator. It's not going to always do that. Let's see. So I would reciprocate both sides, 1 over cos 64. You also could think about it as cross multiplying and then divide both sides by cos. I don't know. There's a bunch of ways to. Right, and then if I multiply both sides by 4 here. Are you guys getting like okay at recognizing which trig ratio to use at which time? Like that's the thing that's going to be like kind of the newest piece for you. So 4 divided by cos 64 is what I need. And I got 9.1. Right, so that's 9.1. So 9.1 plus 5. I don't even know what color to. There is going to be 14.1 for that hypotenuse. So moving towards the big triangle now. I know 5, I know 9. I've got to find one of these angles. Let's find V. Actually, I still didn't find this one, did I? This one's going to be what? 36? I think you guys can do that. All right, so angle V. I know. Question. Did I make a mistake? I made a mistake. Color me embarrassed. Sorry. Yeah, and as I say, oh, that was such a classic Waddy. That's a good quote right there. You got to timestamp that one. I think you guys can do this. I'll just write 36. Everyone can do this. This is the easiest thing to do, as I do it wrong. Classic move, right? Can't hear what you're saying. Is what? Oh, SOHCAHTOA, yeah. Yes. Yeah, and right when you guys get your tests, whether today or whenever, I would recommend just write SOHCAHTOA right on the top of the test. Not where your name is, because that's where your name should go. But if you were to name your child SOHCAHTOA in the future, that would be amazing. Yeah, a summer camp for trigonometry. Did you go to trigonometry camp this summer, guys? Like, oh man, that'd be so great. I wish. I'm going to invent it every summer for my poor 3 children. Like, it'll just be me and them hanging out all summer doing trigonometry. All right, yeah. Ooh. So cosine of V, the adjacent from V's perspective. Why did I pick cosine here? Because I know the adjacent and the hypotenuse, so cosine compares those things, right? I'd rather compare things I know than things I don't know, right? If I have 2 unknowns in an equation, I'm going to have a system to solve, and usually people don't like that. So 9 over 14.1, how do I solve for V? So cosine inverse. Yep. Yeah. So let's see. So second cos inverse of 9 divided by 14.1. Close parentheses. I got 50.3 degrees. And then angle T we can find. Angle T is going to be what? Looks like, what's that? Why did I keep doing the wrong thing? 39.7, yeah. There we are. And I need to find t-dubs. Let's do Pythagorean Theorem, why not? Is TW a hypotenuse or a leg? Leg. Alright, so t-dubs squared plus 9 squared is equal to 14.1 squared. T-dubs squared plus 81 is equal to, calculators, 198.81. Subtract 81 from both sides. I get t-dubs squared is equal to 117.81. Root both sides. Technically, there's two answers to this algebraic expression, but because we're dealing with geometry, I'm only going to consider the positive. So, root, square root, second answer, 10.9. And you know, do your gut check, 10.9, it's opposite the mediumist angle. Is that true? Yeah, angle V was a little bit bigger than T, and 9 is opposite of the smallest. So yeah, and then 14.1 should be the biggest of all three. All right, well, thanks for watching, internet friends. Adios.